All right, so most of us are familiar with the idea of correlation, or we've definitely heard of it most likely. And so correlation, it's a single number statistic that measures the extent that two variables are related to one another. And the idea behind it is it really provides us two bits of information: the strength of the relationship and then the direction of the relationship, which we'll see here in a little bit. Now, the values of correlation range between -1 and 1. And the idea is if you have a correlation near zero, it pretty much means that there is no linear relationship between those two variables. However, if you get to one of the other two extremes, either -1 or 1, the closer you get to those two values, then the stronger that relationship exists. So if it's a -1, we have a strong decreasing or negative relationship. If we are closer to +1 for the correlation coefficient, we have a strong positive or increasing relationship. So what does this look like? Well, let's take a look at two variables within the Ames data. We have sale price, which we see here on the y-axis, and we have the ground living area. And this is the total square footage of the living space in a home. So we can expect that as the square footage of a home, the living space at least, increases, we tend to have an increase in the sale price. And that's pretty much what we're seeing visually here in this relationship. So we see kind of this positive increasing relationship between those two variables. Now, if we wanted to actually measure this, that's where we can use correlation, right? And so correlation is going to actually provide a single number, a single statistic that kind of encapsulates this relationship. So here we see the correlation between these two variables is 0.7. So since we are closer to 1 than to 0, or also closer to 1 than -1, this is signaling that we have I guess you could say a moderate to strong correlation that is positive because it's a positive number, right? And so we can kind of think about this as, well, we have this kind of positive increasing relationship between these two variables. And that's exactly what this statistic is trying to tell us with this single number. Now, people often say that we have a strong correlation or a weak correlation. But this is really subjective, and it's subjective around kind of the domain that you're in. So some domains, such as the medical field, if you have what we would say maybe like a 0.5 correlation, lots of times in the medical field, that's a pretty strong relationship that exists. They often don't see relationships that strong. So in the medical field, that could be considered a strong correlation because it's somewhat relative. Whereas if you look at other industries, maybe like manufacturing, in the time that you have a conveyor belt running and the output that they provide, they're probably much, much more strongly related to one another. So you may have a correlation that is closer to 1 or -1, right? And so for them, you would need to have a much larger value, closer to 1, for it to be considered strong. So just realize that people use that term, strong correlation or weak correlation, but it's very relative to the domain that you're working in. And also, when you're interpreting coefficients that are not close to the extreme values, right? So if we're not close to -1 or 1 or at 0, it's very difficult to understand exactly what that relationship is. We may have something in our mind, but rarely is it very accurate. And a great game to play is, there's this link here, Guess the Correlation. And if we go ahead and take a look at this, this is a pretty cool game because what it'll do is it'll show you various plots and ask you to kind of guess the correlation. So here we have our X and our Y, and we have a bunch of data points. So we could say, well, this looks like it's a positive correlation, and maybe I'll say it's a point, let's say with 0.6. And we can see that the true correlation was 0.5. So I was somewhat close. Let's look at another one. So here's one, we got some more data points. Looks like there could be somewhat of a positive correlation here, but it looks fairly weak. So I'm going to go ahead and say 0.3. And we see actually the true correlation was 0.36. All right, so again, I was fairly close there. Here's another one. This one, it's tough. I don't see any definitive patterns going positive or like upward or decreasing, negative. And so I'm going to say that this might be closer to like a 0.15, something that's pretty low. Let's see what that is. And there's 0.11. All right. So I'm doing pretty good. So this is a great game to play. It'll show you many different patterns. It'll allow you to kind of guess what your correlation is and then kind of compare it to the actual correlation. So if you get time, I would highly recommend checking that out. One thing to point out is that correlation assumes a linear relationship, right? So whether it's increasing or decreasing, we expect that the relationship is linear. And this is not always the case, right? So it's always important to not just compute a correlation, but to also visually assess the relationship, right? And we can illustrate with these 4 different plots here. So each one of these plots, we have an X value and a Y value, and we have some data points. So we can see in this first plot, this looks like it is a fairly linear increasing relationship between the two. But the second plot here definitely have a nonlinear, some curvature relationship. There's a relationship that exists, but it's nonlinear. In this third plot, we have pretty much a straight line, except we have this one point that seems to be an outlier compared to all the other ones. And in this last plot, we have all our data points, but one grouped way down here in this X value. They all have the same X value, but different Y. And then we have this one data point way up here. So when you look at these, we have very differing relationships that exist, right? Some you may say are stronger relationships than other. But what do you think the correlation is between these? If we take a look, they all have the same correlation. All the correlations are equal to 0.82, right? And so we're not going to go into details in how correlation is computed, but just realize that you can actually have the exact same correlation, but you can have actual relationships that vary significantly from one another. So it's always important to kind of compare the correlation that you are computing to a visual representation of that relationship.